Dr. Vijay Lakshmi is working as a professor in the Department of ECE, Anna University, Chennai. She has more than 17 years of experience in teaching. She has published more than 90 papers in international and national journals and conferences. She has organized more than 10 workshops and has attended more than 40 workshops and seminars. She has guided more than 100 projects in both UG and PG level. She is supervising 14 research scholars. She has established an AICTE sponsored MODROB project for VLSI Lab. She has an endowment award for the top rank holder in PG degree and has 4 cash awards for producing 10% of result in Anna University curriculum. She is a life member in various professional bodies like ISTE and IETE. She has specialized in mobile communication, microprocessor and microcontroller, digital system, computer networking, and neural networks.
Welcome to UGC lecture series, BSc Electronics Harness, Electronics Practical 9. In 8085, we are going to write block transfer. So, how to transfer block of data from one source to another source. So, block of data is nothing but group of data. So, the group of data is loaded in the one location, should be transferred to the another location. We will discuss the logic how to the blocks will move from one source to another. So, consider this is one block which consists number of data 01, 02, 03, 04, 05, 06, 07. So, 7 data I have, I want to move into the another block. So, how to move this 7 data into another block? That should be moved to lower data to be lower, the higher data to be higher. That is, first I will move to 01, then 02, 03, 04, 05, 06 and 07. This is a 1, 2, 3, 4, 5, 6, right. So, how to transfer one block of data to another? So, this is, suppose I call it as source. So, this one is called it as a destination register. So, how did you have any idea how to transfer from one block to another block? First, we have to initialize the address for this block. Suppose I have taken the address as 4200 for source. For destination, I will take the address as 4300. Okay. Suppose if I have a 7 data, then first I want to move the content from 4200 to 4300. Then the next address 4201 should be moved to 4301. So, take the source address as 4200. So, I want to load the 8 data. So, I need 8 address. I started with 0. So, 0 to 7 I need. Four 4205, 4206, 4207. Okay, 8 address because I have a 8 data to transfer. So, in first address I have the data as 05, in the second address 07, in third address 12, the next address 75, then 29, 2A. This is a hexadecimal number, so you can assign any number 04, 10. Okay, 8 numbers I have. Now, I want to transfer the same data to the 4300 to 4307. So, 4301. So, how I want to transfer the data is, first I have to read the data 4200, which is 05 to be loaded to 4300. Then I have to take the next address 4201 the corresponding data 07 will be loaded in 301. Then 4302 will load the 4202 data 12. 4303 have the data 75 which is in that 4203. Next I have to read 4204 data which is 29 to 4304. Next I have to read 4305 with a 2A. 4306 will 04 which is the content of 4206. Now the last data 4307 will have the 1 data 10, right. So completely the 8 data from 4200 to 4207 to be transferred to 4300 to 4307 is the logic. This is a block transfer, one set of data transfer from source to destination. Now we have to think how to write the program. So already we have initialized the memory location, we know the source and destination address. Then what we have to do? We have to limit how much of data to be transferred. So here we have defined as a 8. So only 8 numbers is transferred from source to destination. So now let me recollect what are the instructions are available to initialize the memory location. So LXI H comma the source address I will take it 4200. Then another 16-bit register B register I will take it for storing the destination address, right. This is for source, this is for destination. Now we have to initialize how many bits want to transfer, that is the 8-bit data. So I will take it as D with 08. So for every time we have to write H which represents this is a hexadecimal number, okay. Already H and L register is used for 4200, B and C is used for 4300, remaining general purpose register is D and E. So any one of the register you can assign it or use it. Now what we have to do? First we have to call one of the data from 4200. How to call? Yes, move A comma M. The content of the HL register pair is name it as M register. So it represents 4200 content which is 05, right. 05 is now moved to accumulator. Then what we have to do? One of the data has taken from 4200 is temporarily stored in the accumulator because we have to move to 4300. For memory access it should perform with only accumulator. So we have read it from 4200 via the accumulator. Now this accumulator content should be transferred to 4300. So for that we have the instruction STAXB. STAXB means the accumulator content will transfer to the BC register pair which is 4300. So the accumulator content is now moved to 4300. Okay. So the first data is moved. Then what we have to do? We have to call the next data, then move. The next data is 07. Loading the value 07, the address to be increased by 1, right. Source address and destination address both should be increased by 1 to read and to store the value. So which instruction we have to use for increase the register pair, not register. So for increasing the register pair we have to use INX. INX H. INX H represents the HL register pair value is increased by 1 and stored in the HL register. Suppose the value is 4200, then now the new value 4201. Now I am using the instruction INX B. INX B means the BC register pair is increased by 1 and the resultant value or the increased value is stored in the BC register. Then, so both memory locations are increased. Then we have to transfer this instruction, right. Now the M represents 4201. That one value is moved to accumulator. One value was 07. The 07 is moved to accumulator. That accumulator content is transferred to 4301 by using the STAX instruction, right. So this will be processed till what? So till the D register pair decreasing to 0. So instead of increasing, we mostly our record count value will be initialized, then easy for decreasing. So we have to use the DEC instruction D. So DEC D means when it reaches 0 means what it represents, we have to switch off. So this process will be continued till 8 bits are transferred. This is a program for transferring one block of data to another block. LXI H, 4200 which is a source address where we have the data. LXI B, 4300 this is a destination address where we have to move. Then how many bytes if you want, that should be initialized here. I have selected the D register, so MVI D, 08H. So first I want to read the data from source, then move to destination. So for that I am accessing the first data via M register. So the HL register pair content is called with M. So move A, M means the content of 4200 is moved to accumulator. Now the data is in accumulator, I can easily move to the destination address which is B. So the BC register pair, for storing the content into the BC register pair by using this instruction STAX B. So STAX B, the accumulated content is moved to 4300 by increasing the source location and destination location, it will increase by 1. I am decreasing the counter. Now the counter value is 07. 07 is not a 0, so it will switch over to this location. Now the 101 value will move, 201 value will move to accumulator, then that will stored in the 4201. DCR D. DEC in 8086, now we are discussing 8085 which is DCR D. Okay. So initially the address is 01, right, 01, the content is moved to accumulator. Now that will stored to 301. Now it is increased to 2, this also increased to 2, this value is now 6. So 6 is not a 0, so it will switch over to the program. Now the increased address 2, the content will be moved to accumulator, then this will stored to the BC register pair. Now the address is increased as 3, this is 3, now it is reduced as 5. So it is not a 0, so the third content of source will move to the third content of destination by using these two instructions. Now we increase it as 4, both are become, that is 204, 304. Then decrease the counter as 4, it is not a 0, so we repeat the process, then it will increase as 5, this is reduced as 3. So the fifth content will be moved, then the address is increased by 6, this is reduced as 2, so it is not a 0. So now the sixth content will be interchanged, then it will increase as 7, and now it will reduce as 1, so it is not 0, so it will transfer. Now the seventh content of source and destination will be transferred. Now content is increased by 8, now the register is reduced as 0. From 8, after 8 rotation, now it reaches the 0. If the loop is 0 means it not switch over to the specified location, it will jump out of the loop. Now with the help of halt instruction, we are stopping the program, right. This is a way of program execution in 8085. Now, we will execute the same program in a kit. Before that, we cannot use the mnemonic or the high level language as it is. We have to convert this into the opcode. So, before converting, we have to know whether the instruction is 2 byte instruction or 3 byte instructions or single byte instruction. In single byte instruction mean it consists only the opcode. Okay. In 2 byte instruction, it consists of opcode and operand. Wherever the 8 bit operand we are using, that it called as a 8 bit, that is 2 byte instruction. Instruction with 16 bit representation, which all name it as 3 byte instruction. So, based on the byte, we have to allocate the address for each instruction. So, I will write the program again, LXI H, 4200. Suppose I have planned to execute the program in 4100. So, 4100, in the 100 I have to convert the opcode for LXI H. LXI H is 21. So, I have to write in the address 200 is 21, then 4101 is the lower byte of this address we have to enter. So, 00, then 4102 is 42. So, 3 address we have to give. This for LXI H, 4200. Now, we have to write LXI B, 4300. 4103 value was the value for LXI B 01. It should be referred from the opcode sheet. I will show the opcode sheet later. 4104 next address will load the initial lower byte first, then we have to load the higher byte. These 3 address for loading LXI B, 4300. Now, I have to initialize the instruction for counter MVI D, 08. So, this is a 2 byte instruction, this is opcode, this is operand. So, 4106, the opcode for MVI D is 16. The next address 4107 will give the value of 08. The next instruction is move A, M. For move A, M, the opcode is should be entered in 4108, value was 7E. Then we have to use STIX B. So, this is a single byte instruction which is 4109 02. Next instruction is INX H, INX B, right, for the 2 instructions that are single byte instructions. So, 410, this is not 10 after 9, this is a hexadecimal. So, we have to write it as A. So, INX H, the value was 24. For INX B, 410B, the value was 04. Then I have to use DCR. So, that should be entered as 410C, value was 15. Then we have to use the jump, right, jump on no 0. Here I have given only the star to this location. So, here I have to specify the location where to switch over. So, I will write it here. After C, 410D. For 410D, jump on no 0. This is a 3 byte instruction. So, 3 address we need. In 0D, I have to write it as C2, then 410E. Here, where to switch over? I have to move A comma M. Where is move A comma M? This is a move A comma M instruction opcode. So I have to switch over here 4108. So first I have to write the lower address, then I have to write the higher address which is in the next location 410F. The number is 41, right? So after switch over, the last instruction in the program is halt, HLT. So halt instruction is opcode value was 76. So 41, okay, I will write 41 after F, now it become 10, 76. So after reading 76, it represents halt the program. So this is a way how to convert the program into opcode. The opcode only we can enter into the opcode sheet. Now we will type the program of block transfer. The source address is 4200, destination address is 4300. So I will write the program with the 4100. Next I have to type 21, then 00, then 42, then 01, 00, 43. Next 16, 08, 7E, next 02, next 23, next 03, next 15, next C2, next 08, 41, 76. So this is the program. After typing that, we have to give the input where 4200. So take the location and give the input as, already we have discussed as 05, then next value is 07, next 12, next 75, next 29, next 2A, next 04, next 10. So 8 numbers I have given from 00 to 07. Okay. Next to address you clear it, reset it, now execute, go, starting address is 4100, execute, reset, sub, we have to take the destination address 4300, press next, now given address which is 4200 is 05, next 07, 12, 75, 29, 2A, 04 and 10. Okay. So the data from 4200 of A data is completely transferred to 4300. Summary. In this episode, we have discussed how to read the data from the source and how to transfer to the destination memory location of one data. When we have a number of data, then how to transfer the bulk of or block of data from source to destination have discussed and executed in the 8085 kit. Questions. What is the meaning of move A comma M instruction? How to initialize the memory location? What is register pair in 8085? What is STAXB instruction? Thank you.